Okay, well, welcome to Success Jam class, physics. And just like we did the last time, we looked at the top 10 topics in chemistry, right? I listed the top 10 topics in chemistry. We mentioned organic chemistry, we mentioned acid, base, and salt, we mentioned gas laws, we mentioned solubility, we mentioned electrolysis, and some other key topics. And then we picked one of the topics and we started teaching them. That was on Monday. So the same thing we're doing with physics. Top 10 topics in physics. Tomorrow will be top 10 topics in biology and top 10 topics in Jamb mathematics. Tomorrow will be top 10 topics in biology and top 10 topics in Jamb mathematics. That will be tomorrow. But for today, one look at top 10 topics in physics. I'll list the top 10 topics. If you're praying for Jamb and you don't know any of these topics, you can't blast your Jamb because there are short topics that comes out every year in Jamb. So we'll be looking at the top 10 topics in physics. Please, if you missed our video on the top 10 topics in chemistry, go back to the YouTube channel and watch it. Or you can register with us so you can access the video and watch it. But it's top 10 topics in physics. And first topic, very important topic in physics that you'll be looking at is wave. Class, you can't write Jamb exam and you don't see a question at least on wave motion. Wave. Another pillar of physics, Jamb, is electricity. Everything that has to do with electricity. Electricity. So we have wave. We have electricity, another very key topic in physics, Jamb physics. Waves, everything that has to do with wave. Wave is a very large topic. Electricity is also a very large topic. Wave, we have electricity. Class, you will definitely see question on motion because there are so many types of motion. Is it linear motion? Is it circular motion? Is it projectile motion? Is it simple harmonic motion? Something on motion will always come out in Jamb. Something on motion will always come out in Jamb. Class, you will see question on dynamics, definitely. When you're talking about dynamics, that means you see question that has with forces. I calculate the force acting on this, force acting on an object at a particular point. Dynamics, you see questions on dynamics, force. You see questions on force, definitely. Under dynamics, you can have, let me just list some subtopics, machines. Questions on machines can come out. Question on friction can come out. Question on momentum can come out. Collision. All these are subtopics under physics, general physics topics that you see very, very important. Wave, electricity, motion, dynamics. Dynamics has to do with force, machines, friction, momentum, collision, two body collided, the body was moving this, all under that. When looking at motion, you still have projectile free fall, linear motion, circular motion, simple harmonic motion. Expect something there. Electricity is very broad. Electricity, we have, okay, so talking about key topics in Jamb physics. For electricity, we have the aspect, or let me not just call electricity is very broad. Under electricity, allow me to still put what we call simple AC circuits. The question can come in under simple AC circuits. Simple AC circuits. For the electricity part is very broad. You know, you have static and dynamic electricity, movement when the electricity is at a particular DC and AC. We have direct current, we have alternating current circuits for electricity. Wave is very, very broad too. We have light wave, we have sound wave, we have a lot of things on that way. Wave is a big topic on its own in physics. We have motion. We still have nuclear physics. Just like we have nuclear chemistry, we have nuclear physics. We have what we call it, thermal physics. Yes, thermal physics. They love thermal physics a lot. Thermal physics has to do with heat capacity, specific heat capacity, linear expansivity, area expansivity, volume expansivity. So thermal physics has a lot to do with expansivity, expansion. Remember that when it is applied to a body, expansion of the material is expected. Expansion, thermal physics, talking about heat capacity, specific heat capacity. So thermal physics, everything about convection, conduction, radiation. We look at conduction, convection, radiation, how most of it transfer. Most of it transfer in a body. Thermal physics, so nuclear physics, thermal physics. These are the anchor. These are the foundations that hold Jamb physics. Nuclear physics, thermal physics. Look at that. And we can look at elasticity. We can look at elasticity. Elasticity. This electricity is very broad because you have capacitors here, you have resistors, you have inductors. We look at all those things, you understand? It's very, very broad. Very, very, very what? Broad. Yes, 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 yes. So, key topics in physics, key topics in physics. All these topics you're looking at, they have children under them. They are very broad. Very, very, very broad. Top 10 key topics in physics. Key topics in physics. What else do we have here? Yes. Once others come to my mind, I'll also note them down. But let's have this as the anchors. Of course, talked about motion. You cannot write physics exam. You don't see question on motion one way or the other. Dynamics. This is also very broad. Dynamics, forces, machines, friction, momentum, collision, everything, rigid bodies, talking about rigid bodies, everything that has to do with acting. You see? Kinetic energy. Yes, it's still under this kinetic energy. That is work energy and power. You can still calculate under, put it under work, energy and power. Excuse me. So if you say kinetic energy, mechanical energy, it's still under, it still covers it. You understand? Yes. So that's why I say each of these things, they have children under them. So by the time you have touched all these things, you will still talk kinetic, you still talk mechanical energy, you still talk different types of energy and all that. Today we'll start with wave. You say something? Eh? Machines, yes, machines. These machines here. Is here. Machines. Are you saying machines here? Yes, machines is here. Don't worry, these topics are listed. Almost all the key topics are under it. Anything you may mention anything in physics now, I'll tell you where it is here. Magnetism, yes, yes, that's on that part. Thank you for reminding me. I was about saying that. Magnetism and electromagnetism in physics. Yes, this is the last part. And electro what? Magnetism. Very, very good. We'll be looking at the Lenz's law and Faraday's law of magnetism, electromagnetism. We'll look at all those in magnetism. Yes. That is the one that I skipped. Yes. Magnetism and electromagnetism. Yes. If you know every question that can come out in each of these topics, you won't have any problem with physics. There will be no issue with what? Physics, because everything is here. Nuclear physics is here. Thermal is here. That is it. Anything it. Electricity is here. Wave, motion, dynamics, machine, friction, momentum, collision, work, energy, power. I've almost covered everything in physics if you know this thing. So this is going to be our direction. This is going to serve as what? As a guide for what we are going to be doing. Without much ado, let's start with, without wasting more time, let's start with waves. Let's start with what? Waves. So we now have a direction for chemistry and physics. Chemistry was on Saturday. We listed all the key topics in chemistry, nuclear chemistry, everything. And we started one of them immediately. So today we are doing the same thing for physics, and let's start one of them immediately. There's no time to waste. Like I promised us last week, we'll start teaching this week. I've started already. So to teach, we also go through the past exam questions to see questions under those topics that we are teaching in class. Wave, right? A wave. A wave is a disturbance. A wave is a disturbance that passes through a medium, causing temporary displacement of the medium from its equilibrium position. A wave is a disturbance. A wave, a disturbance. A wave is a disturbance that passes through a medium causing temporary displacement of the medium from its equilibrium position. So, for this class? Okay, settle down. What's your name? Okay, settle down. Causing temporary displacement from its equilibrium position. A wave is a disturbance that passes through a medium causing temporary displacement of the medium from its equilibrium position. Class, note the word temporary. Note the word what? Temporary. Because the displacement is not permanent. The displacement is not what? Permanent. Class, let us say this point A and this point B. And a wave permeates through a medium, causing the medium to be displaced from its equilibrium position. But eventually, the body still returns back to its equilibrium position. Class, this diagram on the board illustrates what happened during wave motion. So this line drawn would mean or would represent the equilibrium position of the body of the medium. So let's assume a body was balanced along this line or was at equilibrium along this line until a wave motion comes in. A wave comes in. And a wave, as we said, is a disturbance. So when the wave comes in, it moves the body, shifts the body from this line, which is the equilibrium position, and the body attains highest points while also attaining lowest points, attaining highest point, lowest point, highest point, lowest point. And class, what is interesting is that the body still returns back to its equilibrium. Notice that it still returns back to this line. Despite going up, down, up, it still eventually comes back here. That's why we say that the disturbance is just what? Temporary. Temporary displacement. Temporary what? Displacement. But class, during that temporary shift of the body from the equilibrium position, some things can be observed. The body experiences, or the medium experiences peaks called what? Crest. And experiences lowest points called trough or valley. The trough or valley is the lowest points attained by the body. The crest or peak is highest point attained by the body. So during wave disturbance, a body will experience high points and very low points. Not just that, class. A body will also experience what we call the amplitude of the body. Amplitude is the maximum. The amplitude is maximum vertical displacement of the body from its equilibrium position. Amplitude. Maximum vertical displacement of the body from its equilibrium position. Maximum vertical. Note the word vertical. Displacement of the body. Maximum vertical displacement of the from its what? Equilibrium position. Amplitude, maximum vertical displacement of the body from its equilibrium position. Now, so class, we said the body experiences highest point called crest and lowest point called trough or valley. And we just defined amplitude. Class, the distance between this equilibrium position and the highest point reached vertically is the amplitude. So any of this thing can help you to get the amplitude. Amplitude. Distance between this equilibrium position and the highest point vertically. This is vertical is the amplitude. Class, we also have the wavelength. The wave. Class, why the symbol for amplitude is A, capital letter A. The symbol for the wavelength is lambda. Lambda. This is how we spell lambda. 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 And the symbol is this lambda. So class, the wavelength is another key definition that we must understand when studying wave. And the wavelength is actually the distance between successive crests, between successive what? Crests or successive troughs. the distance between successive crests or successive what? Troughs. Because thank God we know the meaning of crest and trough now. Crest is highest point attained during wave motion by the medium. This is another crest here. This is another crest here. The trough, or also known as the valley, lowest point attained. Now, this crest and this crest, because they come after each other, they are called successive crests. This trough and this trough, because they come after each other, they are successive troughs. So what are successive crests? Successive crests are crests that follow each other. This comes after this. So they are successive. Successive troughs, on the other hand, are troughs that also come after each other. So the distance, the horizontal distance between this crest and this crest is a wave length. Is a wave, and the symbol is lambda. Or this trough and this trough is what? Is a wave length. That's how we define wavelength, as distance between successive crests and successive troughs. We should write down, we have other definitions we will be looking at. Class, still on wave motion. Class, we can also measure how fast a wave is moving. It's called the wave velocity or the wave speed. Wave velocity or the wave what? Speed. How fast the wave is what? Moving, permeating through the medium. Measure of how fast the wave is permeating through a what? Medium is V. And class, I think we'll now have our first formula that the V, which is the wave speed, is the wave frequency times the wave length, lambda. V is F, which stands for frequency, is the product of the frequency F and the wavelength, lambda. The wave speed V is the product of the frequency F and the wavelength, what? Lambda. The wave speed V is the product of the frequency F, became late. Product of frequency F and the wavelength, what? Lambda. Very important. Now, what is the wave frequency then, F? The wave frequency is the number of cycles completed by the wave per unit second. Is the number of what? Cycles. Number of cycles completed by the wave per unit second. Wave frequency is the number of cycles completed by the wave per unit second. Is the wave frequency. The wave what? Frequency. And class, because of that, we said the unit for wave frequency is hertz. H-E-R-T-Z. Or simply put, Hz. H what? Is the unit for frequency. F. So symbol for frequency is F. Wave frequency F is the number of cycles completed by the wave per unit second. We also have wave period T. Wave period what? T. The wave period what? T. Class, why am I taking my time to teach all these terminologies? Because we frequently use them when solving wave questions. Wave period T is time taken by the wave to complete a cycle. Time taken by wave to complete a cycle. Period T is time taken by wave to complete a cycle. And class, the period T and the frequency F are inverse of each other. The wave period T is 1 all over F. You can also come here and say F is 1 all over T. The important thing is that the period and the frequency are inverse of each. So if you have one, you can easily get the other. Just say 1 all over this. If period is 5 and you're looking for frequency, frequency will be 1 over 5. And if frequency is 10 and you're looking for period, period will be 1 over 10. So they are just inverse of each other. Plus, we could also be asked to calculate the wave number K. The wave number K is 2 pi all over lambda. The formula for the wave number K, wave number. K is what? Wave number. And the formula for wave number K is 2 pi all over lambda, where lambda represents wave length. Where lambda represents wave length. 2 pi all over lambda. Now, moving forward, we need to look at types of waves. Types of what? Waves. Class, we have two types of waves. Types of waves. We have two types of waves. We have the mechanical wave, and two, we have the electromagnetic wave. We have the mechanical wave, types of waves. You're not writing? Your pen is bad. Ask someone for spare pen. Who has spare pen? So you just give up like that. Ask someone for spare pen. Types of waves. One, we have the mechanical wave. Two, we have the electromagnetic waves. Types of waves. One, we have the mechanical waves. Two, we have the electromagnetic waves. Now let's start with the mechanical waves. Mechanical waves are waves. You're not also writing? Okay, write down. Mechanical waves, let's define mechanical. Mechanical waves are waves that require a medium for their propagation. Mechanical waves are waves that require a medium for their propagation. Mechanical waves are waves that require a medium for what? Their propagation. Example of mechanical wave, a very good example is the sound wave. Sound wave. So when looking at types of wave, there are two broad types. One of them requires medium for propagation. So the other of them does not require a medium for propagation. And that's the second one. Electromagnetic waves are waves. Write down. Electromagnetic waves are waves that do not require medium of propagation. A good example is light wave. Electromagnetic waves are waves that do not require any medium for their propagation. So electromagnetic waves do not require medium of propagation. Mechanical waves require medium for their what? Propagation. Mechanical waves require medium for their propagation. Electromagnetic waves do not require any medium for their what? Propagation. Class, we just looked at types of waves. I also like us to look at classes of waves. Class is between types and classes of waves. Class, just like waves can have two types, we also have two classes of waves. One, we have the transverse wave. And two, we have the longitudinal wave. One, we have the transverse wave. Two, we have the longitudinal wave. So let's not confuse types of wave with classes of waves. Class, under types of waves, we put them under two types based on medium of propagation and the ones that, and the lack thereof of medium of propagation. But under classes of wave, we're looking at the wave medium, the relationship between the wave motion and the medium. Class, there are two kinds of relationship that can exist between the wave motion and the medium that is being disturbed. Class, important to note that for a wave motion to exist, there must be a medium that is being disturbed. Because say a wave is a disturbance that passes through a what? Medium, causing temporary displacement of the medium from its equilibrium. So there's a medium involved, right? When you're talking about wave, you can't talk about wave without talking about a medium. So a wave disturbs a medium from and displaces it from its equilibrium position. So there's a medium involved. So class, the direction of the wave relative to the medium, is it a parallel direction or is it a perpendicular relationship between the medium and the wave? Class, this is perpendicular. This is what? Or orthogonal. And this is parallel. This is what? Parallel. That means, class, if the wave motion and the medium are moving parallel to each other, then a type of wave is formed. But if the wave motion and the medium are perpendicular to each other in such a way that is, maybe the wave is moving, the medium is moving like this, and the wave is going like this, or the wave is going like this, the medium is moving like this. So they are meeting each other at right angle. We say what? This is a perpendicular relationship between the wave and the medium. So I remind you again, there are two things. There's a wave, which is the disturbance, and there's a medium being disturbed, right? Now, before the wave came in, the medium was moving on its own, in its own direction. Now, if the medium is moving in this direction and the wave comes in like this, you're going to have a perpendicular relationship and a type of wave is formed. But the medium is moving like this and the wave also comes and meets it parallel to it. Another type of wave is formed. This perpendicular one is transverse. What? A transverse wave is formed here, class. And this parallel one, a what? Longitudinal wave is. So when defining transverse wave, we say transverse wave is formed when the wave motion is perpendicular to the axis of the medium. A transverse wave is formed when the wave motion or the wave direction is moving what? Perpendicular to the what? To the axis of the what? Of the medium. The transverse wave is formed when the wave motion is moving what? Perpendicular. Nobody has a spare pen for her in your bag. Moving perpendicular to the axis of the what? Of the medium. Give her now, at least at all I'm bad. Okay, you follow it up. Yeah, I'll post it, yes. So transverse wave is formed when the wave motion is what? Moving perpendicular to the axis of the what? Medium. And a longitudinal wave on the other hand is formed when the wave motion is moving what? Parallel to the axis of the what? Medium. When the wave motion is moving parallel to the what? Remember that two parallel lines are lines that will never meet, right? They're parallel, they keep going parallel to medium. So what brought about transverse and longitudinal wave is the relationship between the wave motion and the medium being permeated. What brought about transverse and longitudinal wave is the relationship between the wave motion and the medium being permeated. Relationship between the wave motion and the medium being permeated is what brought about transverse and longitudinal wave. Now moving forward, class. Example of transverse wave, funny enough, there are two major types of which is light and sound. The funny thing is that light and sound never occur under the same class, no matter how many way we classify waves. Check, when we look at types of waves, sound was mechanical, light was electromagnetic. Coming to classes now, light is transverse, sound is longitudinal. Class, to be honest, there are two major examples of waves. If you check all my examples, light, sound, every other example of waves are smaller waves, like water waves, radio waves, X-rays, gamma rays. Yes, and those ones are smaller waves. But the major waves are light and sound. Light and what? And most likely, if I give you a question in physics, it will either be under light or under sound. We'll get to that point in physics, like why I want to touch wave is that this wave are also able to teach you everything about concave, convex, all those things asked in physics exam. Convex lens, concave lens, when the mirror is negative, when it's positive. Mirror signs, lenses. Look at all those lenses. Power of a lens. Power of a lens measured in diopters. We look at power of a lens. Study the telescope, magnifying lenses. We look at telescope, formula for telescope. We look at microscope. All those things. Everything has to do with wave. So it's a very, very broad topic. It's very, very broad, but it's something that if you treat it, you're not wasting your time because you know something must drop from it in the exam. You understand? So a short topic is a topic that if there's no way you finish covering it, at least 3, 4, 5 questions will come out from that side in the exam because it's broad. If I open your physics past question now, you might not even know that this question is under wave until I tell you because it's broad. Even when you get to the dispersion of light through a glass prism, right? The color of the light, white light, when it disperses, brings us to Roy beam, right? And the wavelength, which one has a higher wavelength? The velocity too, refractive index, refraction, total internal reflection. All these things are still wave. It's a broad topic, it's a short jam topic. Total internal reflection, the critical angle, all those things. We look at them. Bend stick effect. Look at bend stick effect under waves. Look at real depth and apparent depth. Real depth and what? Apparent depth. All right, so we've looked at transverse and longitudinal wave. The next thing we want to look at now is equation of a plane progressive wave. Equation of a what? Plane progressive wave. Equation of a plane progressive wave. Equation of plane progressive wave. Class, the equation of a plane progressive wave is given by the general formula y equals to a sine theta minus the phase angle or the phase difference. Y equals to a sine theta minus the phase angle or the phase difference. Class, but we know that theta is equals to W times T and our phase difference, because theta represents angular displacement. Theta represents what? Angular displacement. Theta represents angular displacement. Why this phase angle? This is what? Phase angle. A represents amplitude in this formula. A represents what? Amplitude. So y equals to a sine theta minus the phase angle. Y equals to a sine theta. I think we have taken a question on this from when we were doing Jamb past question. Yes. Class. Now the angular displacement theta has a formula which is angular frequency W times time t. This theta is formula for theta is W times t. And formula for phase angle is K wave number times X, where X represents the lateral displacement of the medium. So class, it therefore means that this formula y equals to a sine theta minus phase difference, because this symbol represents phase angle or phase difference. Phase difference. Phase angle or phase difference. Class, if theta is Wt and phase angle is Kx, it means that this formula can change to y equals to a sine Wt because theta is Wt and phase difference is Kx minus K. Because y equals to a sine Wt minus Kx. Class, we can keep going from here by saying that W represents angular frequency. Class, W is 2 pi f, which is f is linear frequency. W is angular frequency, f is linear And k wave number, I think when we're doing that formula, I give you formula for wave number, right? 2 pi all over lambda wavelength. I want to replace w here now with 2 pi f, since w is 2 pi f. And I want to replace k here with 2 pi all over lambda, so that my y is now going to be equal to a sine. My w is 2 pi f, but there was a t here before, so wt, so w is 2 pi f. I did not replace the t, remember t is tt. Minus my k is 2 pi all over what? So I replace my k with 2 pi all over lambda, then you have what? X. Yeah, well done. Class, a question could be asked of us to solve that given a plane progressive wave. Class, do not forget that this is a general equation of a plane progressive wave. It started by saying y equals to a sine theta minus phase difference or phase angle. And we found out that theta is wt, so the theta changed to wt. Phase angle changed to kx. So that y now equals to a sine wt minus kx. But w is 2 pi f and k is 2 pi over lambda. So that y now equals to a sine 2 pi ft minus 2 pi over lambda x. Class, you could be given that the equation of a plane progressive wave is given as, you could be given the question in the exam and say the equation of a plane progressive wave is given as y equals to 2 sine 5t minus 4x. Given that the equation of a plane progressive wave is given as y equals to 2 sine 5t minus 4x. Class, based on this formula I've exposed you to now, if someone now asks you to find the amplitude of the wave, it's obvious that the answer is 2, right? Because in the equation y equals to a sine means that this position is amplitude's position. So any number before the sign represents the amplitude. So a sine means 2 sine means that if someone asks to find the amplitude, just use this one they gave you in the question to mirror the equation you know, which is y equals to a sine w t minus k. This is the equation you know, right? But this is the question they gave you. Y equals to 2 sine 5t minus k. This a means that a must be 2. This sine means that w must be 5. This t minus k must be 4. And this x. It's as simple as that, class. But it might not be presented as simple as this to you. It might not be presented as simple as this to you. But from this equation, you can deduce that a is 2, w is 5, and k is what? 4. But let's take a more challenging question, because it won't be this straightforward that you just see it simply like this. You could be told that the equation of a plane progressive wave is given as y. It's not of you that came late. That's why you see that we're recording this, right? So you can catch up on the part you missed. So anytime we spend to set up this thing, is worth it, because one day it will help you. There will be a day that it is you that this thing is helping, you understand? So that's why we try to record all our sessions. So that any day, for one reason or the other, you miss some parts of the class, you came late, you can go and catch up. Now, why? So if you upload it to the YouTube channel, it will be sent to our private Jamb students group. Please, if you register for this class, you should be added to we have a separate group from we have a general Jamb group, yes. We have a separate private group for only those that have registered. Do you understand? Please. So you can see me. Those that just came in today, you want to register after the class, see me so we can register you for the class. Are you Oma? Are you Oma? Oma is not even here yet. Okay. So we can register you for the class, and then you can be added to the private registered students group. Y equals to, given the equation, y equals 0.2 sine 100 pi t minus 2 pi all over lambda x. Given an equation y equals to 100 pi t. Yeah, good evening. Minus 2 pi all over lambda x. You need my attention? I'm on record though. Let me pause it. So looking at this equation now, they now say find the following. Find one, amplitude. Two, frequency. Three, wave speed. In fact, wavelengths. Four, wave speed. So class, we need the amplitude, we need the frequency, we need the wavelength, and we need the wave speed. Class, what's the easiest one to get? Amplitude is what? 0.2, right? That number before sign is the amplitude 0.2. So our amplitude is 0.2 meters. So this is done 0.2 meters because class, you just take the number before sign is your amplitude. But the other ones won't go down easy, class. You will now say, what equation of motion, what equation of plane progressive wave will I use? If you say A sine Wt minus kx, I don't think this will be the appropriate one for this. Because in this Wt minus kx, there's nothing like lambda coming down here. So I think we might need to break down this equation to W is 2 pi f, right? So A sine 2 pi f t and k is 2 pi all over. So this is what we're going to use. A sine 2 pi f t minus 2 pi all over lambda x. A sine 2 pi f t minus 2 pi all over lambda x. This is the one we are going to use. Class, so that to get the frequency, it means that 2 pi f t must be equal to 100 pi t. We say 2 pi f t must be equal to 100 pi t. You can see that pi will cancel pi, t cancels t, so that 2f is equal to 100 divided both side by 2. F is 100 divided by 2 is 50 hertz. F is 100 divided by 2 is 50 hertz. So you have 50 hertz here. We've just gotten our frequency. Next thing, we're looking for our wavelength, lambda, class. What side does our wavelength lie? It's this other side. 2 pi all over lambda equals to 2 pi all over lambda. Interesting. It looks like my wavelength will be 1. Let's find out. 2 pi, because this side must be equal to this side. So we say 2 pi all over lambda equals to 2 pi all over what? Lambda. So that we will cross multiply, you're going to have 2 pi lambda equals to 2 pi lambda. Now, 2 pi cancels 2 pi. Class, is clear that whatever my lambda is also my lambda here. 2 pi cancels 2 pi. Okay. I'm not supposed to have this. Supposed to have 2 all over lambda x. Sorry, 2 all over lambda x, not 2 pi all over lambda x. 2 all over lambda x. 2 all over lambda x. Or we'll just say pi all over lambda x. Pi all over lambda x. I said that question wrong. Pi all over lambda x. So if we say pi over lambda x, we are going to have, you say 2 pi all over lambda equals, now don't forget that I've seen where I made a mistake. This is supposed to be pi x all over 17, yes. I shouldn't put lambda here again. Pi x all over 17, so 100 pi t minus pi x all over 17. I don't want to waste time start looking for questions in the jump pass to slow down the video. So I'm just forming the question from my head. But I think I'll pause the video and take a question from the jump pass question soon. So we have 2 pi all over lambda equals to pi all over 17. Of course, x cancels x. So we have the 2 pi over lambda equals to pi all over 17. So what will happen now is that we're going to cross multiply so that we're going to have lambda times pi. You have lambda pi equals 17 times 2, 34 pi. 34 what? So that pi cancels pi and lambda equals to 34 meters. Lambda equals to what? 34 meters. I'm just showing you how you solve using this. Lambda is 34 meters. Now, class, if you have lambda and you have frequency, f, and you're asking to find speed, don't forget I gave you the formula for speed. V equals what? F lambda. Do you remember? That V equals F. So you don't need to go back to this equation to get speed V. Just once you've gotten your frequency, you've gotten your wavelength. 50 is frequency. Wavelength is 30. 50 times 34 looks like 1,700 meter per. Confirm that, is that correct? 50 times 34, 1,700 meter per is the wave speed. Because wave speed is frequency times wavelength. So by the time you have got the frequency and wavelength, you can easily get your wave speed. You can easily get your what? Wave speed. Class, this is how you use general equation of wave motion with the equation you are given in the exam to solve for questions like this. When you're done writing, I want us to quickly look at general characteristics of waves. 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 Okay, are we there? General characteristics of waves. One, we have reflection. And what are the ways that waves behave? What are the things you see? Say this is a wave. Because only a wave that will do this. One of the things you see is reflection. Waves undergo what? Reflection. So we are saying general characteristics of waves. General characteristics of waves. General characteristics of waves. Like by entering rainy season. One is reflection. Two, we have refraction. Three, we have diffraction. Four, we have interference. General characteristics of what? Waves. We have reflection. We have refraction. We have diffraction. And we have interference. Let's go ahead to define each of these. Let's start with reflection. Reflection. Reflection is the turning back of wave. Reflection is the turning back of wave on meeting a what? An obstacle. Class. This wave is moving like this and it turns back like this. When this happens, we say what? That reflection has occurred. Turning back of wave on meeting an obstacle or an obstruction. Simple turning back of wave when it meets an obstruction or an obstacle. The turning back of wave on meeting an obstruction or an obstacle. We say what reflection has occurred, has taken place. Turning back of wave on meeting an obstruction or an obstacle. Say reflection has taken place. Class, there are actually two types of reflection. We have regular reflection and irregular reflection. Reflection can be regular or can be irregular, depending on the kind of medium or obstruction that the wave meets. Class, if the wave meets a smooth obstacle, the reflection will be regular. It won't be scattered. So regular, another name for regular reflection is specular reflection. Another name for regular reflection is what? Specular. Regular or what? Specular reflection. And the wave meets an obstruction and is diverted back from where it came smoothly in a regular pattern. Plus, a regular reflection occurs when the obstruction that hits the wave is a smooth surface. When the wave hits a smooth surface. For class, when the wave hits a rough surface, it will show in the reflection class. If the surface is not that smooth, scattered reflection. Scattered is not regular, it's irregular. It's called irregular reflection or diffuse reflection. Another name for irregular reflection is what? Diffused reflection. Irregular, also called what? Diffuse. Regular or specular. Regular or what? Specular, but irregular or diffuse reflection. Irregular or diffuse reflection. So regular reflection is also known as specular reflection, and it occurs when a wave meets what? A smooth surface. When wave meets a smooth surface and is reflected smoothly, it's called regular reflection. When a wave meets a rough surface and is reflected in a scattered manner, we say is what? Irregular reflection. Let's go to refraction now. We're looking at general characteristics of waves. We're looking at general characteristics of what? Refraction is the bending of wave when wave is traveling from one medium to another of different densities. Refraction is the bending of what? Wave when wave is traveling from one medium to another of different densities. Bending of wave when wave is traveling from one medium to another of different densities. Bending of wave when wave is traveling from one medium to another of different densities. Class, the medium wave is trying to travel from one medium to another, in which they have different density or different optical parameters. We have air and we have glass, or we have water. Anyone is okay. Let's say wave is trying to travel from air to water. Class, we don't expect the wave to move freely. Look at this dotted line. This dotted line shows what will happen if the wave did not bend. I may continue the straight path. But it's not possible that, class, even you as a human being, if you are running and you fell into water, the speed you were running way before you enter the water, when you're in the water, will it be the same? The water will reduce your speed somehow, right? Because the density in the water is stronger than that in air. So there's more restriction in water, right? You can't run as fast when you are on land in air than when you're in water. That's the same thing that happens to wave. The wave is moving smoothly here. You cannot continue this smoothly. Class, I put this dotted line to show what will happen if there was no refraction. But class, there will definitely be refraction. Class, this is a normal line. This line you're seeing, this line that is straight, is a normal line that is drawn to help you to show the difference between the incident and the refracted ray. So this line, normally you will draw it. It's an imaginary line drawn perpendicular to the plane that helps you to know what's the difference between the incident and the refracted ray. So we'll call this line the normal line. So class, we're in this period now, we're looking at we're in the wave series. Look at all those concave when the object is placed between this pole and the principal focus, all those things we'll teach you. Principal axis, center of curvature, radius of curvature. Break down all those things. Now, class, I was saying, if this wave continues like this, it means that there's no refraction. But class, there's refraction. The refraction is either towards the normal. This is towards the what? Or away from the normal. So a refraction can either occur towards the normal or away from. And class, we can predict where the refraction will occur. We can predict where the refraction will do what? Class, this is what we call, there are two types of waves travel. Is either wave is traveling from a less dense medium to a more dense medium. Less dense to what? To more dense. Or it is traveling from more dense to less dense. Or it is traveling from more dense to what? Less dense. Is either it's traveling from less dense to more dense medium, or from more dense to what? To less dense. Class, there are three possible mediums, common mediums that wave moves in between the mediums: air, water, and what? Glass. Class, among these three, air is the lowest density, and glass has the highest density. Class, when wave is moving from a less dense medium to a more dense medium, the wave will tend to bend towards the normal. Towards the what? Note that when wave is moving from a less dense medium to a more dense medium, for example, air to water. Class, air is less dense than water, right? Because water is more dense than air, right? So when wave is moving from a less dense medium to a more dense medium, the wave will bend towards the normal. But when wave is moving from a more dense medium to a less dense medium, it bends away from the. So more dense to less dense is away. Less dense to more dense is towards. Please take note. When wave is moving from a less dense medium to a more dense medium, when wave is moving from a less dense medium to a more dense, the wave bends what? Towards the normal line. And when wave is moving from a more dense medium to a less dense medium, the wave bends away from the normal line. So, Clara, I told you we can predict. So, when the wave is moving from air to water, it will bend towards the normal. Why? Because in water, there's more restriction. So, the freedom it was having in air, it will not have it, the thing will shift it. But if it's from something like glass to air now, glass is more dense than air. It will bend away because glass, there's more restriction in glass. When it now comes to air, it's more freedom. So, it will bend. There's more freedom in air than in water. So class, take note of that. So when bending, what is bending of light or of wave generally, when it's trying to travel from one medium to another of different optical parameters or of different densities, of different optical parameters or of different densities. Now, let's go to the third one, diffraction. Let's look at diffraction. Class, they usually ask in Jamb, in which of these two features of wave does bending occur? Bending occurs in refraction and diffraction. That's where bending of wave occurs where? In refraction and diffraction. And class, the funny thing about refraction is that when wave moves from one medium to another, every parameter of the wave will change except one. Class, they can ask you which of the following remains unchanged during refraction of wave. Class, the wavelength will change, the velocity, the speed of the wave will change. Class, of course, know that someone you can't moving as fast in air as in water, right? So speed will change, everything will change. One thing remains, the frequency will remain which of the following properties of wave remains the same or unchanged during wave motion from one medium to another? What's that thing that remains unchanged? The frequency remains unchanged. Now, diffraction. Diffraction is the bending of waves when they meet an obstruction. It's the bending of waves when they meet an obstruction. Bending of waves around corners. Class, a wave is trying to pass and then there's a major obstruction. It now goes and bends around it. It goes around it to pass around. When that occurs, we say what? That diffraction has occurred. Diffraction. A wave meets an obstacle and it still wants to pass. So it goes around the obstacle. It's the bending of waves around corners or edges when it meets an obstruction. It will go around the edges of that obstruction and bend around it. It diffracts. Diffraction is the bending of waves around corners or edges when it meets an obstruction. Bending of waves around corners or edges when it meets an obstruction. Bending of waves around corners or edges when it meets what? An obstruction is diffraction. Let's look at interference now. Interference. Interference of wave now, class. Interference is the interaction between two or more waves to produce a new wave of higher or lower amplitude than the two interacting waves. Class, interference is interaction between two or more waves. Interference is interaction between two or more waves to produce a new wave with a higher or lower amplitude than the two interacting waves. Interference is the interaction between two or more waves to produce a new wave with a higher or lower what? Amplitude than the two what? Interacting waves. Class, there are two types of interference. We have constructive interference and we have destructive interference. We have constructive and we have destructive interference. Two types of interference, constructive interference and destructive what? Interference. Class, if you have a wave, this is one wave, and this is another wave, and when they combine, they now produce a third wave. So this is wave 1 and this wave 2. They now produce wave 3 like this. Class, look at the amplitude of wave 1. Look at the amplitude of wave 2. So let's call this A1. Let's call this A2. But look at the amplitude of wave 3 that they formed. The third wave formed from these two interacting waves has a bigger amplitude than the two interacting waves. When this happens, we say constructive interference has taken place. So constructive interference occurs when the new wave formed has a higher amplitude than the two interacting waves. Constructive interference occurs when the new wave formed has a higher amplitude than the two interacting waves. We say constructive interference has taken place. Constructive interference occurs when the new wave formed has a higher amplitude than the two what? Than that of the two interacting waves. But class, in destructive interference, the opposite is the case. The third wave formed, we have a lower amplitude than the two interacting waves, class. In destructive interference, the third wave formed, we have a lower what? So it's destructive. So the new wave formed is smaller than the two interacting waves. For destructive interference, the third wave formed has a lower amplitude than the what? Two interacting waves. The third wave formed has a lower amplitude than the two interacting waves. So we have constructive and we have what? Destructive. Let us take some questions. Let's take a question from your Jamb past question. This one does not require you to solve anything, so you are lucky. They just said, which of the following types of waves needs a medium for propagation? Which of the following types of wave needs a medium for what? As simple as that. Which of the following types of wave needs a medium for propagation? A. Radio waves. B. X-rays. C. Sound waves. D. Light waves. Class, what's the answer? Sound wave, right? So sound wave needs a medium because it's a mechanical wave. Good. They said a transverse wave and a longitudinal wave traveling in the same direction in a medium differ essentially in their a transverse wave and a longitudinal wave traveling in the same direction in a medium differ essentially in their A, frequency, B, amplitude, C, direction of vibration of particles of the medium, D, period of vibration of the particles of the medium. What do you think is the answer? A transverse wave, I'll come again, a transverse wave and a longitudinal wave traveling in the same direction in a medium differ essentially in their A, frequency, B, amplitude, C, direction of vibration of the particles of the medium, D, period of vibration of the particles of the medium. Class, the answer is C, direction of what? Vibration of the particle of the medium. Direction of vibration of the particle of the medium. Class, I'm seeing several wave questions, but we have not gotten there yet. You know, I have taken them. Look at dispersion of white light. That's ability to separate into components, colors, but we'll get there. Telescope, linear magnification, total internal reflection. There are a lot. Wave must come out. A lot. By the time we are done, you should be able to answer even more of this. A lot of wave questions I'm seeing here. Even this one that relates velocity of sound to temperature is here. I'm actually looking for a question that requires us to use the formulas we have given so far, which is V equals to F lambda. F is 1 over T, wave number here and there. But let us see. Okay. Class, everybody, you need to get your jam pass question. We need, from next week, we need to start a serious challenge, jam pass question challenge, whereby we'll be taking 1 year per day. Everybody will go and solve, will come to class, resolve. We can keep Friday for that. Friday will just be jam pass. We're using Friday. You can use Monday, Tuesday, Thursday to teach. Friday, everybody that will come and revise. The ones you don't know, the ones you are giving here, they could come and revise. You understand? So from next week, everybody should have gotten their jam pass. So this is a serious plan. We have a target. We're not just teaching for teaching's sake. We want to have direction in what we are doing here so that your results can reflect the efforts. So please, everybody should get their jam pass question so that by next week we can start, okay, this day we are doing so and so course. Everybody go and do it this year. Revise it together, see what you scored, correct yourself, go again. Don't wait to jam. So you don't have too many things to do at the same time. You have to start it now. We have to start it now. So from next week, please get a jam pass. I will recommend this checkpoint. Contains all your courses there and then in one. You can use it. If you prefer another one, it's still okay. Just make sure you have a good jam pass question. Look at this question now. Although an object is placed 15 centimeters in front of a plane mirror. Please be fast. My light will soon go off. An object is placed 15 centimeters in front of a plane mirror. An object is placed 15 centimeters in front of a plane mirror. This is still under wave, but it's under plane mirror reflection. An object is placed 15 centimeters in front of a plane mirror. If the mirror is moved further 5 centimeters away, away from the object, find the distance between the object and the image. Find the distance between the object and the image. Find the distance between the object and the what? I'll come again. An object is placed 15 centimeters in front of a plane mirror. An object is placed 15 centimeters in front of a plane mirror. If the mirror is moved further 5 centimeters away from the object, if the mirror is moved further 5 centimeters away from the object, find the distance between the object and the image. Another question. The distance between two successive crests of a wave. The distance between two successive crests of a wave is 15 centimeters. The distance between two successive crests of a wave. Another question. The distance between two successive crests of a wave is 15 centimeters. And the velocity is 300 meters per second. And the velocity is 300 meters per. And the velocity is what? 300 meters per second. Calculate the frequency. Calculate the frequency. Calculate the frequency. Class, waves comes out a lot. I've seen plenty of wave questions. Just that I've not. When the sound wave goes from air to water, the wave property that does not change is it. I've taught it just now. When a wave goes from air to water, the wave property that does not change is its A, amplitude, B, velocity, C, wavelength, D, frequency. Answer is frequency. It's here. Did I just say it in class now? It's in the Jamb past question. It's here. It's here. I know what Jamb. I know what. If we follow us very well, we know what we'll do. You clear your Jamb. You just follow it. Go and get the Jamb past question. Let's start working. Let's start working, please. Everybody go and get this. So once I know that everybody has gotten it, I can now point 1 year. So everybody go and do this here in chemistry today. Tomorrow go and do this here in physics. You understand? Work together, you solve, see your progress. By the time you go back to that year next week, you are getting better. The more you do a particular thing, you're getting better. Practice makes perfect. Class, let's attempt the question that we're given. Let's end today's class with these two questions. An object is placed 16 centimeters in front of a plane mirror. If the mirror is moved 5 centimeters further away, so an object is placed. Like if this is your mirror, object is placed 15 centimeters, right? If the mirror is moved 5 centimeters further away, it's now here now. What is the question saying? Find the what? Object and the image. Class. The mirror is moved 5 centimeters, where the object distance is still now 20 centimeters. Now what? Class, if good thing about a plane mirror, we'll go to in our next physics class, I'll teach you reflection through plane surfaces and curved surfaces. A plane surface is a plane mirror. A curved surface is like a concave or convex mirror. Class, on one property of plane mirror is that there's lateral what inversion of the image to the object. Meaning that if you're standing in front of a mirror, your right will not be your left in the mirror image. Lateral inversion. If you put a letter L in front of a mirror, you see something like this, lateral inversion. So it's not complete inversion. Another importance of a plane mirror, another key point about a plane mirror is that the object distance U equals to the image distance V. Class, if you stand 5 centimeters in front of a plane mirror, the image forms also 5 centimeters behind the mirror. Of course, the image formed by a plane mirror is virtual. Is what? A virtual image is formed by a plane. It's not real, is what? It's virtual. But object distance equals to image distance. So class, if the object distance is now 15 plus 5, 20. The image distance is also going to be what? V is what? 20 centimeters. They ask us to find the distance between the object and the image. Class, the image will be formed 20 centimeters also behind the mirror. They didn't say find the distance between the object and the mirror. Distance between the object and the image. So from here to here is 20, class. Total is what? And from here to here is also what? 20. What's total distance between the object and the image? 40. 20 plus 20. 40 centimeter distance between the object and the image. Because the image formed by a plane mirror is behind the mirror. But the same distance as the object distance. Because the object was placed 15 centimeters in front of a plane mirror. Mirror was now moved 5 centimeters backward, right? Meaning the total object distance is now 20. 15 plus 5. Now the image distance is also going to be what? 20. Whatever happens to the object is reflected in the image. Now, distance between this point, object, and image in this point is this 20 plus another, giving us 40 centimeters. The second question, so we can round up for today, said the distance between two successive crests of a wave is 15 centimeters. Class, what did they just give you? Is it not wavelength? Did we define wavelength in this class? The distance between two successive crests of a wave is the wavelength. So they didn't want to tell you that the wavelength is 15 centimeters. They said distance between two successive crests of a wave. Are you there? 15 centimeters. And the velocity is 300 meters per. We're asked to find the frequency, F. Class, let's make F self formula. We know that V, velocity equals to frequency times wave. Let's make frequency set of formula. That's what we're looking for. Divide both side by wavelength. Divide both side by wave. Frequency is velocity all over Lambda, right? What's our velocity? 3. What's our lambda? 15. 300 by 15 looks like 20. 20 hertz. Class, the frequency of this body is what? 20 hertz. Is it meter already? Okay, this is centimeter. Our wavelength is centimeter. We have to convert to meter. Divide by 100. Yes, very, very important. That will be 0.15 meter. Please do not use it in centimeter because our velocity is in meter per seconds. So 300 divided by 0.15 is what? 2000? 2000 hertz. Correct. Yes. Convert to meter. Always convert to meter. So we're done with today's class. We'll see you. Will reconvene tomorrow by 4 p.m. Thank you very much.